Okay, what we're going to talk about today then is we're going to start sort of our discussion on combined stress. And combined stress, as the name would suggest, is really going to be a topic that takes a look at what happens when we combine two different types of stresses. All right? And there's a lot of instances of this, especially in the civil field, that we should be aware of and we should know how to handle. So far in this class, we've talked about a number of different stresses. I mean, you know, at the very beginning, we talked about direct stress, which was stress like maybe a tension stress or a compression stress or a bearing stress. Even a shear stress like on a connection, we called that a direct stress, or a simple stress at least. And then just, you know, not too long ago, we started talking about bending stresses. And that was a completely different type of stress. And then we were looking at beams, and we also looked at shear stress. And that was, again, a little bit different than what we had talked about originally with direct stress. So, you know, in the most basic sense, you know, combined stress is going to be or is going to consider techniques that we can use when we happen upon situations that have different types of stresses. And like I said, in the civil field, this occurs a lot. You know, we have things like pre-stressed concrete beams. Okay? Now, I don't know how much you know about a pre-stressed concrete beam, but I'll sort of just graphically sort of tell you how they work. Does anybody know what a pre-stressed concrete beam or a pre-stressed you've heard the term pre-stressed concrete before? Okay? Well, here's the way it works. You know, we can go out there in the field and we can build a building or, you know, a facility, and we can build that with concrete that is normally reinforced. That is, it's got the steel bars, they're tied together, we put formwork up, we arrange the steel bars in a certain manner, and then we pour the concrete, the plastic concrete, into the form, and the concrete hardens around all the steel. Okay? That's what they call conventional reinforced concrete or normally reinforced concrete. A different aspect of that is to actually manufacture elements like beams in a, I'll call it a factory. You might actually hear them talk about manufacturing these things in a yard or a casting plant. All right? What they'll do is they'll take, you know, again, formwork and whatnot, and maybe even some conventional reinforcing. But the big thing that they have is they actually have these steel tendons or these steel cables that they place in the concrete forms. All right. Now these steel cables, some people might call them tendons. There's different types and whatnot. Basically, what they are is they're made up of individual wires. So people might talk about a half-inch cable or a half-inch tendon, but it's not a solid steel cable. It's actually a series of usually 7 sort of wires that are sort of wrapped around, almost like, you know, like a rope might be sort of spun around. That's what they call a strand or a tendon, or some people might call that a cable. So anyway, before they even get ready to pour the concrete, you know, they set up their forms, okay, and usually this is based on having very repetitive types of members that they want to make, all right, and they string the cables or the tendons through there, and then they anchor them at the edges, you know, the front and back of the forms, okay. They anchor it, and then they pull on this cable. Now this is before the concrete's even there, okay. They pull on this cable, and then they they basically, you know, anchor it on the other end. So now this cable is in there and it's stretched, you know, really tight. Okay? Now they come in, they pour the beam, and they fill the forms with concrete. They wait till the concrete gains its strength. And then they go ahead and they take the forms off. They release the anchorage, you know, at the anchorage, they release these cables. What do the cables want to do? Cables want to snap back. But they can't snap back because they've got all this concrete in the way. Okay? So what kind of force does that put on this concrete element, this concrete beam? Compression force. Okay? Well, you know how to calculate a compression stress, don't you? Well, how do you calculate a compression stress? What's the formula? P over A, right? Force over area. Okay? Well, so that's a pre-stressed, you know, concrete beam. Except, notice what I also did here, and this is typically what happens too. I didn't put the cable right at the middle of the concrete beam. I sort of put it down maybe towards the bottom a little bit. So not only is this going to want to put a compression force on it, but it's also, because it's not right at the centroid of the shape, what's that going to have a tendency, you know, if I was putting it right at the centroid, there'd just be a compression stress here. But now, since I put it down at the bottom, what's it going to do to the beam too? It wants to bend it. That's right. There's a moment created here because of this force and this distance. We call this distance an eccentricity, an eccentric distance, an offset distance, a distance that, you know, occurs because we're not loading it right at the centroid. But you're absolutely right. This puts a bending moment on it. It wants to twist it. So this thing actually, the beam actually wants to flex up in the air like this. And it's, you know, it's just been released from the form. So you said, hey, we got a bending stress on it too. Well, my question to you would be, do you have a bending stress on it at the same time that you have the compression stress on it? The answer is yes. So what does that mean? Well, it means that these two effects are combining with each other. And that's what we want to learn about a situation like this. How do these combine together so that we know, you know, what the maximum stress is, or what the stress is at the top side of the beam or the bottom side of the beam, and things of that nature. Okay? Now, let's go to a practical question. Why do this? This seems like a lot of work. You know, wouldn't it just be better to go out in the field and put your normal reinforcing in a form and go ahead and do this? I mean, why do this? I mean, you got to ship these to the site, blah, blah, blah. Why do it this way? What do you mean weather?
They're expecting a lot of rain or it's snowing and they're putting up a structure concrete tank drying.
Okay. Well, yeah, the yard, the place that they manufacture these, is usually this would be done outside too, right. But it could be done in a big, you know, sort of like open shed type building or whatever. If nothing else, it's more controlled than project conditions. I mean, if you had to make 12 of these, you should be able to make all 12 relatively the same, right? So it's much more controlled. The other thing that you're sort of coming up when you start talking about project and whatnot is I don't have to wait to install these once they're ready in the factory. I can ship them to the project and they're ready to be installed, right? What about that concrete that you pour on site? When is it finally ready? Well, it's ready. It probably takes 28 days, more or less, to be able to gain its full design strength. So the installation of the construction with this, the process could be much faster. Okay? But there's one more thing. If I put pre-stresses in here, you know, I said, hey, it sort of flexes this up in the air, you know, that means I'm putting stresses in it to do it. Well, if these stresses are sort of opposite in nature of what's going to be there after this is loaded, then I can make this a smaller member. So that normally reinforced concrete member, maybe that beam had to be 20 by 40. But maybe this pre-stressed beam can be 15 by 30. Okay? Now that you might say, well, that doesn't sound like a lot, but I'll tell you what, you know, if you're building a parking garage or you're building a, you know, building, I mean, headroom height is, I mean, that's everything. So, you know, if you can shave 10 inches from floor to floor to floor off, you know, headroom height and clearance height if you're in a parking garage or whatever, that's a big deal. So anyway, that's just an example of where you're likely to see combined stress.